I'm just gonna
There we
put my stopwatch on.
Yeah.
Okay, so we ready? We good?
Yeah.
Okay. So today we're going to present our experiment on the change in forest ecology within Point Pleasant Park, Nova Scotia, following Hurricane Juan. And this presentation is made by myself, Julia.
Quinn.
And Kate.
Okay, so in terms of past research, there have been longitudinal studies on forest succession, but there have been few on Acadian forests. And the limited research on Acadian forest succession does not follow an Acadian forest after a natural disaster to observe changes over time. Instead, they focus on specific questions such as the relationship between forest harvest and succession, or how the abundance of one species changes during succession. There has only been one published study relating to Point Pleasant Park post-Hurricane Juan. However, this study focuses on how users of the park emotionally recovered from the hurricane and not how the park changed from an ecological standpoint. So, for some background information, succession describes how a community gradually changes after experiencing a disturbance, and succession can be primary or secondary. In primary succession, geological changes happen to an existing substrate or create a new substrate. In secondary succession, disturbances remove community members but do not change or create substrate. And during succession, it's normal to observe changes in species such as abundance, richness, diversity, and evenness. You can also notice abiotic changes such as temperature, humidity, light, availability, and soil properties. So in Nova Scotia, the landscape is covered with lots of forests, and these forests are Acadian forests, which are unique to the Maritime provinces and northeastern states. They're composed of mainly spruce, maple, birch, fir, cedar, beech, ash, hemlock, poplar, larch, and pine trees. A great example of Acadian forest disturbance and succession is Point Pleasant Park in Halifax, Nova Scotia. This park is specifically important to the Mi'kmaq Nation, since they believe that the spirit of the warrior Armandou lives there and guards them from the dangers entering from the ocean. They refer to this area as Armandou Kati, or the Place of Spirits. However, in 2003, Hurricane Juan hit Halifax. It was a Category 2 hurricane that removed 70% of the trees in the park. Our research focuses on secondary succession in Point Pleasant Park following Hurricane Juan, and as established, longitudinal studies are rare because of the time commitment required. As well, most longitudinal studies and observational studies on succession in forests do not happen in Acadian forests. Moreover, most studies on succession seek to answer a specific question instead of generally observing how the forest changes over time. So this experiment will be unique in that it is a longitudinal experiment that gives a broad idea of succession in an Acadian forest. So our question generates 6 hypotheses. For our research objectives, we're looking to answer the question by testing the following hypotheses. So the first hypothesis here is that, sorry. So the experiment answers the question, how have the overall forest community, dominant species, and community metrics changed in Point Pleasant Park following Hurricane Juan? So from this research question, we've generated 3 sets of hypotheses. The first set relates to how the overall forest community changes. The null hypothesis is that there is no change in the overall forest community of Point Pleasant Park between 2004 and 2023. The alternative is that there is a change. The second set of hypotheses relates to how the density of the dominant species changes. The null hypothesis is that there is no change in the density of the dominant species of Point Pleasant Park between 2004 and 2023. The alternative hypothesis is that there is a change. Finally, the third set of hypotheses relate to how the species richness changes. The null hypothesis is that there is no change in the species richness of Point Pleasant Park between 2004 and 2023. The alternative hypothesis is that there is a change. Based on these hypotheses, we made 3 predictions. We predict that the forest as a whole will increase in density and diversity until it reaches its climax community. We also predict that the dominant species will remain the same but become more dense and the overall species richness will increase. To test these hypotheses, we gathered data from the trees in Point Pleasant Park annually from 2004 to 2023. We then analyzed this data to observe any trends between these 2 dates.
So our study took place at 6 sites in Point Pleasant Park, Nova Scotia, and the sites were spread out at different locations in the park, and they acted as replicates for the study. Analysis was conducted annually from 2004 onward after the impact of Hurricane Juan in 2003. Point Pleasant Park was used for this study because it was highly disturbed by Hurricane Juan, so we can study the secondary succession at this site. Because data was not collected in 2005, 2007, and 2016 because of hurricanes, and also not in 2020 because of the COVID-19 pandemic. And due to weather and other unforeseen circumstances, not all sites were sampled every year. The data was collected at each site by measuring the diameter at breast height, or 4.5 feet off the ground, using a diameter tape. Each tree was also identified to the species, and data was collected on the density of each species. To analyze the data, we used linear regression analysis, which allowed us to see the trends and how the forest community is changing over time, as well as make predictions for the future. This allows us to test our hypotheses about how the overall forest community, the density of dominant species, and the species richness have changed in Point Pleasant Park after the impact of Hurricane Juan in 2003.
For our results, we found that diversity in the park has steadily increased. The data we collected to determine the effects on diversity from secondary succession was routinely assessed. It shows a consistent increase in diversity, which is symptomatic of early stage secondary succession. The forest is growing and changing every day, with its Shannon diversity index changing from 0.5 to 2 over the course of the 15-ish years.
So the two dominant tree species in Point Pleasant Park are the red spruce and the red maple. So here we have the density of both plotted on two separate graphs, and on the y-axis we have the density of the tree, and this is the number of trees present within 400 square meter quadrats. And on our x-axis we have the year. So as you can see, in 2004, the red spruce has a density of 1 and the red maple has a density of 0. So the red spruce was the dominant species immediately after Hurricane Juan. However, the density of the red maple increases at a much faster rate than that of the red spruce. So in 2022, the red maple has a density of 38 and the red spruce has a density of 4. So currently the red maple is the dominant species. So we used linear regression analysis to examine how the density of red spruce and red maple in Point Pleasant Park changed between 2004 and 2022. And to do so, we collected data on both species from Point Pleasant Park annually. There was a weak positive relationship between red spruce density and time, with our R-squared value being 0.1, our F value being 8.72 with degrees of freedom 75, and our p-value being 0.004. So given that the p-value was less than 0.05, we reject the null hypothesis and support the alternative hypothesis that there is a change in the density of the dominant population in Point Pleasant Park. There's also a weak positive relationship between the red maple density and the time. The R-squared value for this one was 0.9, F value was 17.4 with degrees of freedom 75, and the p-value was 7.9 to the power of negative 5. So given that the p-value here is also less than 0.05, we reject the null hypothesis and support the alternative hypothesis that there is a change in the density of the dominant population.
To examine how richness has changed in Point Pleasant Park after Hurricane Juan in 2003, we measured the number of species per 400 meters squared annually from 2004 to the present. We used regression analysis to explore how the species richness has changed over time. This can be seen in Figure 6. There is a significant positive relationship between species richness, the number of species per 400 meters squared, and year, which was R-squared value of 0.66, F statistic of 142.2, and a p-value of 2.2 times 10 to the negative 6. These results showed that species richness has increased in Point Pleasant since 2004, and this trajectory will likely be maintained as species richness continues to increase until the forest reaches its climax community. Our results yielded a very small probability value for species richness, so therefore our null hypothesis that richness did not change was rejected, which supported our alternative hypothesis that species richness increased during the period of secondary succession after Point Pleasant Park was hit by Hurricane Juan. This finding agrees with published work, such as Turchin 2016, that found species richness to increase in Point Pleasant Park between 2006 and 2016. These findings are important because they show that in secondary succession after a hurricane, species richness will increase. We can predict that species richness will continue to increase in Point Pleasant Park because it has yet to reach its climax community.
As for the state of succession that the Point Pleasant Park Forest is in, we believe that it's in somewhere of a mid to early succession, as it's still increasing in diversity and density every day, which would take away the possibility of it being in a later state succession. Because it is an urban park, we do have some different effects than you would see as a naturally occurring forest. Most particularly is that HRM, when it put out the survey originally about what to do to help Point Pleasant Park, the number one thing that people wanted to prioritize was preserving what it once was. They wanted it to go back to what it once was. And so they've come to they have to compromise of how well they're going to preserve what was there compared to what should be there technically in an ecological perspective, because Point Pleasant Park was an even-aged old-growth forest that was planted by people so many years ago. The comprehensive plan put in place by HRM also acknowledges that when managing urban forests, you have to choose between preserving natural ecological patterns and prioritizing public demands such as durability in case something like this were to happen ever again. Traditional knowledge that we can implement into that could change how our understanding and act works around Point Pleasant Park would be the 7 generations understanding, which is the thought of thinking of how all of your actions are going to affect your people 7 generations down the road, and constantly thinking how your choices affect others.
So finally, we wanted to take a moment to thank everyone who helped us in the process of completing this experiment and assembling this presentation. So first off, this is a longitudinal study, and it would not be possible without the students who took this class before us and collected the data in previous years. We also owe a huge thank you to Dr. Allison Schmidt, the lab coordinator for this course. She designed and facilitated this experiment, as well as analyzed and graphed all of the data. She also actually provided us with the data this year when our lab was canceled due to rain, and of course guided us through this entire process by answering our questions. The other guiding figure in this class is Abigail Target, our demonstrator marker, and she helped guide us when making this presentation by answering any questions and providing detailed feedback on our draft. So yeah, that's our presentation, and thank you for listening.
How long was that?